Hi everyone. So I am here with another tutorial for implementing TensorFlow's object detection API, which will be detecting a multiple number of objects and even localizing them. So this is an example image of all the day-to-day life objects which are being detected and recognized by this API. So what is TensorFlow API? So this API has been trained on Microsoft Coco dataset, which has approximately around 300,000 images and of 90 categories or classes. So some of these classes I've mentioned here, like dog, mobile phone, clock, chair, teddy bear, person, TV, laptop, vase, or vase, and traffic light, birds. So actually, there are five different models, the recognition detection model. So one is a single shot multi-box detector SSD, as you know it, with mobile net, an SSD with inception. Then there is a region-based fully convolution network, you know it, RFCN with ResNet, and RCNN with ResNet 101, and this fifth one, faster RCNN. So these are the five dataset, and the speed and MAP is minimum average precision. So higher it is, the better it is. So you can see this is a lightweight one and fast one. This is also fast one. This to a medium and this to a slow. So first let's see what at the end of this video what you will be able to do it. So you will be able to recognize any objects in your home or anywhere. So you can see this. I have uh, few objects here, and it's bottle, cell phone, cup, dining table, remote, which somehow it is misrecognizing as I don't know why. Yeah. So cup, cell phone, remote, dining table, and even on the TV, it's recognizing the TV, the person. So it's recognizing all those persons, and even far above, I have a clock there. That's not a TV, that's a door. So you can see it's pretty good API. So yeah, let's see how we implement this. So we go to Google, obviously, and then you just Google TensorFlow Object Detection API. The first link is the code of the API. So they have mentioned here, they have given a small description, and this is the image which in which a lot of objects have been recognized, and they have mentioned everything about installation to how to use it. So first let's hit the installation. That's what important for us. So in this installation, let's see, they require protobuf 2.6, pillow, lxml, tf slim, jupyter notebook, matplotlib, and tensorflow. So you need to get your tensorflow, and you need to install a whole lot of this. So one way which worked for me was to install TensorFlow 1.3.0 or the latest TensorFlow, so that you can do it. So I usually use Anaconda. So uh, you can install TensorFlow. I'm using Anaconda 3. So anyhow, like TensorFlow in Windows is supported in Python 3 version only. So you can install TensorFlow with pip install TensorFlow, and it should install everything for you. So I have already installed it. So you can see uh, it's I have NumPy, I have 6, I have protobuf 3 greater than 3.3.0, I have TensorBoard, and I guess even I have this LXML which they showed, HTML5 lib, and I don't know. So basically I get everything what TensorFlow provides me. So either you can do it pip install, or you can download the wheel file corresponding to your system. So for me it was TensorFlow 1.3.0, Python 3.6, 64-bit system. So I downloaded this and installed it. So it's pretty simple. So once you downloaded the TensorFlow, so yeah, basically you'll get all the setups. Let's see what they need more. Yeah, so for me I I guess I got everything. And so far so good. So once all the modules have been installed, so you can move ahead. So since I'm using Anaconda, the Jupyter Matplotlib are automatically installed. If it's not installed for you, you can simply use pip install command and you can install whatever the modules are needed. Next, we need a proto of compilation to compile all the .protos file into a .py file. So we need to download this protalk module. So we can do this using here. You just go to Google protobuf releases and you go to the first link, and yeah, so you make sure you download the latest version. Protocol buffer 3.4 is the latest one, and let's look for a protoc of for our system. So for my system it's Windows, so I'll download this one. If you have Mac OS or Linux, you can download the respective. So let me download this. So this is one thing that we need. So I've already downloaded it, so I'll cancel it for now. And then we need to download the model file. So this TensorFlow API detection. So this was an installation. Let's go to this. Yeah. So basically you go to models and you clone or download it. So I'll download it as zip, and this one also I've already downloaded it, so I'll cancel it. So for me it is in this folder, and let me just replace the previous extraction. So see what exactly is this. Okay, so far so good. And once this is done, so now we can move into the implementation of the code. Okay, so yeah, but first thing is that we need to what do you say, yeah, compile the protobuf. Where is that line? Yeah, and that we have to do from TensorFlow models directory, which we just downloaded it. So let's go here, and in our TensorFlow models is models master. So let's just name it as models. Okay, and let me open a prompt and let's go to this location. So I'm using Anaconda 3. You can do it through your Windows CMD if you have necessary libraries installed and the paths defined. Okay, so let me go to the place where this is. It's in my tutorials. It's in TensorFlow object detection inside models. Great. And what was the instruction? Let's copy this compilation. I've copied it here, and let me run this. So obviously protalk is not recognized as internal or external command. So let's give the full path where the protalk is located, or either you can add it into system path, or it's better you give a full path. So for me it's located in my tutorials and here inside bin. So I'll give a full path of this here, and yes, so I pasted it, and let's give uh, // so yeah. So now why do we need to compile this line? So if you go to the place where you have downloaded your models and you go to object detection, where here, and there is a directory named protos. So inside this there are all protos folders. So actually I have already compiled it. So if you haven't compiled it, you will not get this pb2.py. There will be only box predictor.proto. So once you have compiled, you will get box predictor pb2.py. Okay, so let me execute this. So in your folder you will not get this pb2.py fast recognition pb2.py. It will simply be faster crn box coder.proto. So in order to get all this, we just run this and it is compiled, and you will see this in your directory. These all are generated. So once we have compiled, we are good to go. And there is a tutorial Python notebook given here. So if you go to the object detection module, so there is a IPython notebook here. So let's go there and let's understand the different modules. So these are obviously different modules that you need to import it for execution, and this is for your matplotlib show, imshow and all that. This we load the labels from the utils directory, and then yeah, so this is the model name which we want to use. As I said in the presentation, there are 5 models. So let me go here. Yeah, this one. This is located here in object detection g3 doc detection model zoo.md. So you can use any of the models for your object detection and recognition. So this one is the lightest, fastest, so we'll go for this one. But accuracy wise, this is the best, as its MAP is highest 37, but it's pretty slower. But for now, let's go with this. Okay, so where is this? Yeah, so they are giving a path for downloading this, and this will be, and the model, like when you download this model, inside this you will get a saved pre-trained frozen model, and it will come in the name of frozen inference graph.pb, and the path to labels are mentioned here. And then this module, it will download this model from internet. So you can either download this or from internet by running this line of code, or you download it explicitly from here by clicking here and then just paste it there, and you can just read the star file. Okay, great. Then we load the model, the actual model, the path to CKPT, the frozen inference model, and then we load the map, load the label maps. And this unit is just to convert image into numpy arrays. But if you are using OpenCV, then we don't need to know that, because OpenCV's module cv2.read automatically does that. And this one just gives a path of a set of image directories, and this is finally we run the session of TensorFlow and execute it. Okay, so let's go here. First, let's open a Jupyter notebook, and oh, sorry, great. So when you open Jupyter notebook there, you will see where did we open it? Ah, we didn't open it inside object detection. Okay, so inside object detection, there is object detection tutorial.i Python notebook. So this is my Python notebook, and either we can run it here, or the way I like is I just save this file and I run it in editor window. So I will just save this file as, I'll download this file as python.py file, and let's save it here. Let's open where it is, and let me cut it. And okay, sorry, and I will go where my model is. So inside this model, inside object detection, where is object detection? Here. So I'll just paste it here, and so you already see that there is object detection tutorial.ipynb. And one more thing is so this full model is kind of 166 MB, I suppose. And if we actually need only this object detection module, so we can just copy it outside and use it anywhere we want. So this will be just your 4.8 MBs. But you have to make sure that first you kind of compile the the proto buff, so that you get, oh, it's here, yeah, so you get all this proto file as py file. So you have to do that line which I showed before, and this should contain this one. Okay, so either we can run it inside this, or we can just take it outside and use it anywhere. So now let me open a spider editor, and yeah, spider. It will take some time to open it, but not much. Let it load. Great. and let me open a new project. Okay, I got you. Let me open a new project, an existing directory, and it's here in mod object detection. Okay, let's create it. So nice. So we have this object detection tutorial.py. We have downloaded it, the Python notebook as .py. Let me just rename it instead of .1. Great. Now let's open it and let's execute it. Okay, cool. So now let's execute it block by block. We get this. So since I am running it in this path, this is my working directory. I don't think I need to append any path. So let's just import the labels. Yeah, okay, I got this. So actually, when this object detection was inside model, so when we are calling from there, it calls from object detection dot protos import string lab map2.py. But now we are already inside object detection, so we don't need this. From protos import should work. Okay, so let's run this now, and good, it's working. So now this is the model file. You can change the model as I told you earlier. Let's run this, and now this two line will download this model from internet. Okay, so if I run this, it will start downloading, or another way is you just download it and paste it here and then retrieve it. So it may take some time for me. So I have, okay, it's downloading here. So I'll pause the video till it downloads. The file is downloaded for me in this format: ssd mobilenet coco.tar.gz. Okay, and now we need to load this file and get this frozen inference graph.pb. So I'll run this block of code here, and so yeah, you get it. So it extracted from here, and inside this we have the actual pre-trained model. Great. Now let's load this model which we have just downloaded. So it will load it. It will take some time, not much. Great. Now let's load the labels. It's loaded, and this block, as I told earlier, is to convert an image into numpy array. And this is a path to test images directory. So this is the test image directory that they have provided, and there are two images. One is the image of dog, and the other one is a image near beach somewhere. So let's run this, or let's first give the path. And now this is the main session which will run, and inside this session we'll loop over the test image path directory over all the images, and then we'll get the classes to which it belongs, and then we'll draw the bounding boxes. So let's run this block of code, and we should get uh, detected images here. Yeah, nice. So we got this, you can see. So the dog image, the two dogs are detected along with the score, and this one we see the person kite all detected. So great. So we see that it's very easy to run this once we compile and download all the required dependencies. But this is not our aim. We want to run it in real time, like I showed you earlier, through webcam. So let's do that. First of all, let me make a new file called detection uh, object detection tutorial webcam. Okay, let me get rid of this tutorial webcam.py, and let me copy all this stuff because everything we need, just there are small changes. Okay, nice. Let me open new IPython console. So the only change what we have to do is here. So instead of reading it from your image directory, we have to read the frame from the camera. So for that, we are going to use the OpenCV module. So if you have used OpenCV, you'll be knowing we import cv2, and then we initialize a camera object as cv2 dot video capture, and we give a device id. Device id means which webcam you want to use if you have more than one webcam attached to your system. And in this part, for instead of this, let me comment out this and use a while return. So I'll say what this exactly is. Oh, I have some indentation issue. So let's make return as true. Sorry. And let's give it a colon here. And now we are not reading any image file, so let's not do this. We are not even converting it to array, because when OpenCV reads it, it just reads it uh, as an array only. Okay, so it will be like return and image np. Let's keep what they have kept here for a while. Image np equal to cv, oh, sorry, it's not cv, it's cap dot read. So whenever the image is read, the return value will be true, and whenever it's true, it will loop over. And when the image is not read, red value will be false, and this loop will close. Okay. So now we have started reading it, it will execute, but for showing it, we have to use the cv2 command. So I have just downloaded it from here. Let's copy this and I'll explain you what exactly this does. Okay, so instead of plot.imshow, we are using cv2.imshow, the name of your window, and then we are resizing it just to have a larger view. And then we use cv2.waitKey. So what actually waitKey does is it waits for that amount of time. For that amount of time, it will show the frame. It's in milliseconds, I guess. So if you make it cv2.waitKey 0, then the image will be just there. It won't close, it won't destroy itself. But for this, after 25 seconds, it will destroy. And this is to get a input from the user. If you press q button, then this will break and this entire code will stop. Great. So this is what we need, so let's run it. And okay, we take this, we don't need this path, we need this to load. And actually, yeah, let's load the file path name, but we don't need this because we already have it, the frozen inference.py from the previous execution. So I don't think we need this. We need this. We need to load the model. It's taking a little bit of, it's loaded. And let's load the labels. And we don't need to load this module also, as I told, OpenCV gives the images array. We don't need this module also. And finally this module. Let's run this and see how it works. So yeah, it's recognizing the objects. Wow. So let's see it here. It's chair, dining table, bottle, cell phone, remote, chair. That was supposed to be a teddy bear. It's not recognizing it. Okay, let's go there. That's a laptop. That's a TV. And it's recognized teddy bear there. And let's go to the clock. Okay, so it's recognizing the clock also. And let's see if it recognizes my system. So yeah, it's saying it's a TV screen and inside TV. Oh my god, that is interesting. That's a reflection actually from this camera to the window, and you can see that is a cool thing that I didn't know. Let me play with it. Oh my god, this is really cool. Great. So you saw this. It's working. It's very easy implementation. So you can try this out, and hope you enjoyed this session. So try this out. And one more thing, I'll post this in my GitHub. So this object detection module, so you will have this object detection tutorial.py and webcam.py, so you need not go through all this again. And also you need not compile the protos, because all the protos have been compiled here, so you can directly download this module from my GitHub and run this object detection webcam.py, and it will run for you. So great, hope you enjoyed, and try different things and keep on learning. Bye.